Okay, so for 5.3, we're going to be balancing redox reactions again, but this time we're going to be looking at what happens in acidic or basic conditions. So balancing in neutral conditions is relatively simple because of the absence of oxygen and hydrogen atoms. Now, once these are introduced, as they are in our acidic and basic conditions, the balancing becomes just a bit more challenging. So we're going to follow the same steps very close to those of our neutral conditions with just a couple extra steps. So in step 2, when I mentioned something called a major atom, I'm just talking about an atom that is involved in a change of oxidation number. So not dealing with the possibility of oxygen and hydrogen atoms here unless they're the ones that's being either oxidized or reduced. So these are steps, and some of these are going to seem very familiar to our last section. So general steps in balancing acidic conditions. So in acidic conditions, we would expect to have hydrogen ions present to produce then hydronium, which gives us acidic conditions. So that's what we can expect as our end result. So for step 1, you are once again going to split the reactions into 2 halves. So we'll have an oxidation half and a reduction half. Step 2, you are going to balance the major atoms of each half reaction if necessary. So those are the atoms that are involved in changing with their oxidation number. Step 3, now this is one of the new steps that we've inserted. We're going to balance any oxygen atoms by adding water molecules, and then we're going to balance the hydrogen atoms by adding H+ ions. So this here is our new step. We're only able to add oxygen in the form of water, and then we'll be adding hydrogens in the form of hydrogen ions. And this is going to give us that acidic condition. Step 4, next we're just going to make sure the balances are charged by either adding electrons on our product side or reactant side. Step 5 is the same here. We're going to be multiplying each of these half reactions if we need to, so that the electrons will cancel each other out. And then step 6, we're going to add those 2 halves together and the electrons should cancel out. But you might have some extra hydrogen ions or water molecules that appear on either side of the equation. If they're on either side, well then they can be canceled out. And we'll look at that in the questions to come. So we're going to work through one question, going step by step for an acidic condition. I'm going to be taking up the whole page, just showing step by step. Once you get the hang of this, you can simplify and actually turn a couple steps into each other. So it's not going to take the entire page every single time you're balancing. But we'll start with step 1, which is to split the equation into 2 halves and then make sure our major atoms are balanced. So I know this is in acidic conditions, so I know I'll be adding hydrogen ions. So first, let's look at the oxidation number of every substance here. So I know that my hydrogen is going to be +1. My oxygen here, this is not a peroxide, is going to be -2. However, there are 2 of them. So in total, I'll have a -4. My entire molecule here, all the oxidation numbers must equal 0. So if I have 2 times 2, -4, plus 1, that's going to give me -3. So in order to cancel out -3, my chlorine here must be equal to +3. My iodine here is -1. Chlorine by itself in its natural state is 0. And then here I have hydrogen, iodine, and oxygen. So my hydrogen is +1, my oxygen here is -2 still, but my iodine now must be a total of +1. Because I need all this to balance up to 0. So this is a plus. There we go. So which one here is my oxidation And which one here is my reduction? Well, my oxidation would have increased in oxidation number. So if I'm looking here, I go from -1 to +1. But notice how I'm not going to just write out my iodine here. I'm going to keep it as the compound. So my iodine was oxidized in this complex here. And reduction, well, which substance here decreased in oxidation number? That would be my chlorine. But I'm going to keep the entire substance together. So my next step, and this is combining with step 2, is just to balance those major ions or atoms. So here I have iodine, that's balanced. On this side, I have chlorine 2 and 1, so let's make sure I have 2 chlorines, right? I'm balancing the atoms that changed oxidation number. I'm not right now worrying about oxygen or hydrogen. Now my next step, step 3, is where I'm going to balance the oxygens by adding H2O, and I'm going to balance my hydrogens by adding a hydrogen ion. So let's write these out again. So for my oxidation, I have this. I need to make sure 1 oxygen on this side. I need an oxygen on this side. So I am going to add H2O. So now 1 oxygen on either side. But now when I'm going to balance my hydrogens, I have 2 on this side and only 1 on this side. So I'm going to have to add another hydrogen in the form of a hydrogen ion. So oxidation, there's balance. So for reduction, I have that. Now I'm going to first balance my oxygens. So I have 2 times 2. I have 4 oxygens on this side. I need 4 oxygens on the other side. I can only add them in the form of water. So I'm going to have 4 of these water molecules. Well, now let's balance my hydrogens. I have a total of 8 hydrogens on this side. I need 8 hydrogens on this side. But I already have 2. So I'm going to add 6 more, and it has to be added in the form of a hydrogen ion. All right, now I have these balanced. So my step 4 is balance the charge. So I'm going to rewrite these. Now, keep in mind, you won't need to rewrite them over and over and over again like I have. I'm just really wanting to show you these steps. So I know my oxidation is losing electrons. So my electrons are going to have to show up or appear on my product side. So I'll leave room for that. Now, how many will I need? Well, I have a -1 total charge on my reactant side, +1, so I'm going to have to get that to -1. I will have to add 2 electrons. So now I have -1 charge on either side. Now for reduction, I know reduction is a gaining of electrons, so I am going to leave room for some electrons on my reactant side. Now, in order to balance this out, I noticed that right now I have +6 on my reactant side, but a total of 0 on my product side. So in order to get this side also to 0, I'm going to have to add 6 electrons. All right. So step 5, I'm going to multiply them by an integer so that my electrons in each half reaction are the same. I'm going to find a common multiple of each of these. Now, I have 2 electrons and 6. So I can actually get this to equal 6 by multiplying the entire reaction by 3. So this 3 is now going to multiply every coefficient. And then I should see that my electrons will be balanced out. So let's apply that. So this 3 hits now every single substance. So now I'll have 3 water molecules, 3 iodines, and then 3 of all my products here, and a total now of 6 electrons. Now I didn't do anything to my reduction. It was already at 6 electrons, so I'll just rewrite it out again. Okay, so step 6, I'm now going to add these all together, canceling out my electrons. I should never have remaining electrons in my balanced equation. So this means I'm going to add together all my reactants, add together all my products. Okay, big long reaction here. Well, my very final last step is to cancel out, let me write this down, cancel out extra water or hydrogen ions. So if they appear on either side, I can cancel them out, as you'll see here. So I have 3 water molecules here, 4 water molecules here. Well, this 3 will cancel out 3 on this side, and I am left with just 1 extra molecule of water. What else can I cancel out? Well, I have hydrogen ions on either side, so this 3 will completely cancel out these 3. So I had 6, so now I just have 3 left. So you should never end up with the same substance on either side of your reaction. You can always simplify. So how does this affect our final balanced reaction of this redox equation in acidic conditions? Well, our final equation is going to look like this, where I have an extra 3 hydrogen ions on my reactant side, and a leftover 1 water molecule on my product side. So now every single atom here is balanced, and my charges are all balanced. I have +3, -3, overall of 0, 0 on this side. It is all balanced, and I notice this in acidic conditions because I have this hydrogen ion. So really make sure you know these steps. So now we're going to go towards balancing a base. A little trick is going to be used. So in essence, the equations will be balanced as an acid using the exact same 7 steps that we did, but then at the very last step, we are going to convert it to basic conditions. So this trick involves changing our hydrogens, ions that are our acid, into water by adding hydroxide. So we're getting rid of those hydrogen ions, what is making it an acidic condition, by adding hydroxide. So this step just uses the fact that whenever I have hydrogen ions and hydroxide, I'm going to be producing water. So for example, suppose we have a segment of a balanced half reaction in an acid that looks like this, where I have six hydrogen ions to get 3 water molecules. And I'm wanting to convert it to a basic condition. Well, I'm going to add 6 hydroxides to get rid of these 6 hydrogen ions. However, remember, I want to keep this balanced. So I need to add, whatever I add to one side, I need to add to the other. That means I'm also adding 6 hydroxides to the other side. What now happens is the hydrogen ions from above react with my hydroxide to produce water. So now I have a total of 6 water molecules on my reactant side. Still have this 3 and now 6 hydroxide. Well, I have water molecules on either side. These can be simplified. 3 will take away the 3 here, so I'm left with 3 since I started with 6. And now I have a total of 3 water molecules to give me 6 hydroxide. And that is how I've converted an acid now into basic conditions. So we're going to do this in our balanced redox equation. So steps 1 to 5 are identical to as if we were balancing in an acidic condition. But then before we finish, we are going to add hydroxides as needed to combine with any hydrogen ions in order to form water. Once all of our hydrogen ions have been converted, we can then remember to balance it out. Also note that whatever hydroxide you add to one side, you must add to the other. Now, these two halves can be added together. The electrons should balance out. And you can cancel out any extra water or hydroxide that appears on both sides. So let's work through one more question, where we're now balancing in basic conditions. So I know I'm going to be dealing with hydroxide at some point. So before we find out what's our oxidation and what's our reduction, we need to know our oxidation numbers. So for my oxygen, I know that they're each going to have a -2 for that oxygen, but there's 4 of them. So a total of -8, but this has to equal -1, so my manganese must have been +7. For the sulfite ion, my oxygen here is also -2, but getting an overall -6 because there's 3 of them. I know that my sum of all my oxidation numbers must equal -2. So if this is -6, my sulfur must be +4 to get this to a -2 sum. On this side, I have -2 for oxygen again, but there's 2 of those. Sorry, let me write a better 2. -2. Overall charge of 0, so, or sorry, an overall -4 for my oxygen because it's times by 2, but overall compound has 0, so my manganese must be +4. Then for my sulfate, each oxygen contributes -2, but there's 4 of those, so -8. This means my sulfur must be +6 to keep that at a -2 charge. All right, so which one has increased in oxidation number? Which one's being oxidized? Well, I'm looking at this and it seems like it's my sulfur. It's going from +4 to +6. So I'll take the entire ion that contains sulfur on either side. Next, what's being reduced? Well, I know it's not going to be my compound with my sulfur because that's what's being oxidized, but what has decreased in oxidation number here? My manganese went from +7 to +4. So that is what I'm taking for my reduction equation. Now let's look at balancing these main atoms. My sulfur's balanced, my manganese balanced, I'm good. So for step 3, I'm now going to be balancing my hydrogen and oxygen by either adding water or adding hydrogen ions. So for my oxidation, I have SO3 minus 2, SO4 minus 2. Now I have 4 oxygens on this side, 3 oxygens. I need to add another oxygen, so let's add just 1 water molecule. That balances out my oxygens, but now my hydrogens aren't balanced. So I have 2 on this side. Let's add 2 hydrogen ions on my product side. Now everything appears to be balanced. Next, I'm going to have MnO4 minus, MnO2. Well, I have 2 oxygens, 4 oxygens to 2 oxygens. I need to add 2 waters. But now I have 4 hydrogens. I need 4 hydrogens on this side. Now my hydrogens and oxygens and all my atoms are balanced. For step 4, I'm going to be looking at balancing my charges. I know that for oxidation, I'll be losing electrons, so I can expect my electrons will be on my product side. And I'll just need to make sure that it's balanced. I have a -2 charge on my reactant side, -2 plus 2, charge of 0. Well, I need 2 electrons then to make each side a -2 charge. I know I'll be adding electrons to my reduction. But I'll have to figure out just how many I'll need. Well, my product side here has a 0 charge. On this side, I have +4 minus 1, so a total of +3. Well, to get this to 0, I need 3 electrons. All right. So next, let us balance those charges by multiplying the entire equation by an integer. So I have 2 and 3. Let's get them both to 6. So I'll multiply my oxidation half by 3, multiply my reduction half by 2, so that each one will end up with 6 electrons. So distribute the 3 here. Three times 2 will give 6 and 6. For reduction, do the same thing, but now I'm distributing the 2 to each one, 6 electrons, 2, -1, 8, 2, and 4. Okay, now step 6 is when it's going to get different. For step 6, now I want to remove these hydrogens by adding hydroxide. And I'm still going to be doing these separate. So if I want to get rid of my 6 hydrogen ions here, let's add 6 hydroxides. But if I add it on this side, I'll be adding it on this side. Now I want to get rid of my 8 hydrogens here. So let us add 8 hydroxides. And then I'll have to be adding 8 hydroxides on this side. So my hydrogen and hydroxide are going to be forming water. Let's write out how that's changed things. So for oxidation, now I have a total of 6 hydroxides, but still these 3 waters, because those haven't changed on my reactant side. Well, a total of 6 waters and 6 electrons. For my reduction, still have these 6 electrons. But now I have a total of 8 water on my reactant side. and 8 hydroxides. Okay, so now we finally reached a point where we can combine them together. So we're going to do that. Think of this as I am just adding all these together. But watch what I can cancel out here. So actually in this step, I'm just going to cancel out my electrons. But notice how I can combine my waters. They're actually going to add together. So my overall step 7 now, making sure I'm keeping track and that I don't lose any substance. I'll add my waters together, so that's a total of 11. Then on my other side, a total of 10, but then 8 hydroxides. So really just make sure you're not losing anything. You're keeping track of everything there. We're dealing with a lot of different ions. Okay, my last step is just simplifying. So I have a total, let's start with water. I have a total of 11 and 10. So these 10 will fully cancel out 10 on this side, so I'm left with 1 remainder. What else can I cancel out? Well, let's look at my hydroxide. I have a total of 6 and 8, so this 6 will fully cancel out 6 on this side. I'll be left with 2. So now I can simplify to get my final redox balanced equation in basic conditions. So once again, I should only have hydroxide on one side. I should only have water on one side. All my atoms should be balanced. All my charges should be balanced. Aha, there we go. I know that I don't have any hydrogen ions. I only have hydroxide present. This makes sense because this is in basic conditions. So this is how you would balance a redox equation in basic conditions. We're going to treat it just like it would be an acid, but then convert it in the last couple steps here. And just make sure everything's balanced. So I would go slow and really make sure you're following all these steps within these questions. And then once you feel more comfortable, you can start combining these. Like you wouldn't rewrite it out every single time. You could balance, add the electrons, multiply the coefficients, add the hydroxides, almost all in the same equation, but just making sure you are keeping track of these steps. Balancing the atoms sometimes, or the atoms sometimes gets forgotten and charges end up being balanced first. This is going to give you an incorrect total charge, perhaps. So make sure you're balancing those main atoms first. Then you are balancing hydrogen and oxygen if we are not in neutral conditions. Then you're balancing those charges. Then you're converting it to a base if it is in basic conditions, and then you're just simplifying. So try all these questions. Let me know if you have any of your own.